Guess what? More parabolas. Yes, there are going to be like 5 days where we spend time on parabolas. Um, Mainly because like parabolas are sort of more likely to be found um, by you when you do problems than any other kind of graph. But anyway, part two, we're focusing on parabolic functions. Okay, remember a function is just where I put something in and something comes out, like the vending machine. I punch in a number and then a treat comes out, right? And this particular function we're looking at is called f, and it is a function that when I put x in, all this stuff happens to x, right? It's 2 times x plus 3 squared, right, plus 5. And then a number will come out. So what I'm going to do first is I'm going to replace f of x with y. And then I need to turn this into the standard form for the parabola. So I'm going to subtract 5 from both sides so that I get it into the form of y minus 5 is equal to 2 times x plus 3 squared, which means my vertex is negative 3 and then 5, right? And then my a value is 2. Now, of course, we have this axis of symmetry, which we talked about. It's going to be right in the middle of the parabola, and it's going to go through x equals h, right? In this case, x equals negative 3 is going to be my axis of symmetry. So I'm going to draw this parabola with the information that I have with the vertex, the a value. That's really all I need in order to draw the parabola, and then my little tricks of over and up and all of that. So my vertex, again, is negative 3, 5. My a is 2. My axis of symmetry, my axis of symmetry is x is equal to negative 3, which I will draw, and then I'll plot that first vertex. Now, of course, I'm going over 1 up by a, and then over 2 up by 4 times a, and then over 3 up by 9a if you wanted to do that. Just notice that, like, if I'm going over 1, I'm going up by 1, that's squared. If I go over 2, I'm going up by 4 times a, right? The 2 is squared. And if I go over 3, I go up by 9 times a, the 3 is squared. So I'm going to do that. I always go back to my vertex before I shift over and up, right? So vertex, I just go back to the vertex, go over 1, up by a, over 2, up by 4 times a, which is going to be 8, and then I'm going to connect these dots. And the other side, of course, is just reflected across of that dotted line, right? Like it's a mirror. So I'm just going to mirror it on the other side, and it's very easy. So notice that the lowest point of this parabola is right there where the vertex is. We would call this a minimum value for the parabola, for the function. So the minimum value of the function is going to be 5, right? Every other value of the function is larger than that because it just continues to point upwards. Now the domain is, what are the possible x values? Well, I don't really have any restrictions in the x-axis. It can be all reals. And then my range, lastly, which is like the y values that I get, y is going to be greater than or equal to 5, which I kind of base off of that minimum value, right? Y can be any number that's greater than that, but it starts at 5, so it's any number that's greater than or equal to 5. Let's go ahead and do another function. This time we're going to have to complete the square, but always replace your h of x, your f of x, your g of x, whatever it is, with y to start. And then I'm going to subtract 6 from both sides, so I get y minus 6 is equal to negative x squared minus 6x. So I need to complete the square here, but I do not like that I have negative x squared minus 6x. So what I'm going to do is I'm going to multiply everything by negative 1, both sides of the equation by negative 1, so I can just get it out of my way for now, and then I'm going to move it back eventually. But what I get is negative y plus 6 is equal to x squared plus 6x. So I'm going to do my 2 alpha business. 2 alpha is going to be equal to 6, where alpha is equal to 3, and then alpha squared is equal to 9. So I'm going to add 9 to both sides, which gives me negative y plus 15 is equal to x plus 3 squared, once I factor that into x plus alpha squared. Then I'm going to, again, like I moved a negative 1 at the beginning, so I'm going to move it back. So I multiply everything by negative 1, and I get y minus 15 is equal to negative x plus 3 squared. So my vertex is going to be negative 3, comma 15. And then my a is negative 1, so it's going to be a downward-facing parabola, downward opening parabola. And then my axis of symmetry is x is equal to negative 3, just like the last one. So I'm actually going to use this same picture, and I'm going to just plot my new vertex, which is negative 3, 15. So it's the same x coordinate, but it's going to be farther up. And then I'm going to have an a value of negative 1, so it's going to be facing down. So I'm plotting this. I'm counting up all the way to 15, right, which is up there, so now you can see it. And I'm going to go over 1, and then down by 1, because this is just a standard a, right? It's a equals 1, so it's down by a, which is down by 1. And then I'm going to go over 2 from my vertex, and then down by 4 times a, which is just going to be 4. So I just go down by 4, and then I reflect that on the other side of the parabola and connect my dots, okay? We're always going to draw these parabolas the same. You might notice that the black parabola is a little bit like fatter or wider than the pink one, right? Because the pink one had an a of 2, which means it's kind of stretched out. But anyway, this time, since it's facing down, we actually have a maximum value, right? The parabola doesn't go any higher than that vertex point. So the maximum value of this parabola is going to be 15. The domain, of course, is all reals because there's no restrictions on my domain. And then the y is going to be less than or equal to 15, right? Anything less than or equal to 15 because that was the highest point, and then it can have anything lower than that. So let's look at this more specifically. Let's say that I'm looking for, or I have another function. We're just going to do another function here. But this time I want to give the minimum or maximum value, and I want to give the vertex. So without drawing a graph, can you determine whether it has a minimum or maximum? What is it? Okay, let's talk about this. So we have y is equal to x squared plus 8x plus 6. I subtract the 6 from both sides, so that way I have room to complete my square. 2 alpha is equal to 8, alpha is equal to 4, alpha squared is equal to 16. So I add 16 to both sides of my equation, and I get y plus 10 is equal to x plus 4 squared quantity, right? So then I get this parabola, and I'm going to take a look at this. So I know that I have a positive a value. I also know that the vertex is -4, -10. Because I have a positive a value, that means my parabola is going to be facing up, which means I'm going to have a minimum value, not a maximum value, right? Because it can go up forever. I'm going to have a minimum value. And the minimum value is going to be -10. Okay, how do I know that? Well, I just look at the k coordinate of my vertex, right? And that is actually going to give me my minimum, right? And it's going to give me my maximum also if it's a downward facing parabola. Basically, I'm just looking to the k value. So h, right, determines your axis of symmetry. It's the line x equals h, whereas k determines your minimum or maximum value. Okay, and it's just going to be like minimum equals k or maximum equals k, depending on which way your parabola is facing, right? If it's facing downwards, it's going to have a maximum value, a highest point. And if it's facing upwards, it's going to have a minimum value or a lowest point, right? So we have now another problem where we have to find the vertex, the domain, the range, and the zeros. So first thing I'm going to do is I'm going to set y equal to g of x, so replace that. And then I'm going to multiply both sides by 2, so I get 2y is equal to 6x, 6 plus x times 4 plus x, and then I distribute that. And then I'm going to subtract that 24 that I get from distributing, and I get 2y minus 24 is equal to x squared plus 10x. So 2 alpha is equal to 10, alpha is equal to 5, alpha squared is equal to 25, which I add to both sides. And I end up getting 2y plus 1, that's negative 24 plus 25, right? And then I factor the other side into x plus 5 squared. Now I'm going to bring my 1/2 back at the very end, so I multiply both sides by 1/2, and I get y plus 1/2 now is equal to 1/2 times x plus 5. So this is a upward facing parabola, right? Upward opening. It opens up because there's a positive a value, which means it's going to have a minimum value. And the minimum value is always equal to k, right? So it's going to be -1/2 is my minimum value. And then every other point that the parabola has is higher than that -1/2. The domain is, of course, all reals because there's no restrictions on x, right? If there are any restrictions, it would be a restricted domain. But in this case, every value is okay for domain. Now the range is going to be y is greater than or equal to 1/2, right? Because -1/2 is the minimum value and every other y coordinate is higher than that. So the range is y is greater than or equal to -1/2, right? That's where the parabola is touching. Now I have to find the zeros. So if you recall, the way we find the zeros is I set y, or I set the f of x, the function, equal to 0, and then I solve for x. So I'm going to have 0 plus 1/2 is equal to 1/2 times x plus 5 squared. Okay, so this is 1/2 is equal to 1/2 times x plus 5 squared, right? Because 0 plus 1/2 is just 1/2. I'm going to multiply both sides by 2 to get 1 is equal to x plus 5 squared. And then I take square root of both sides to get plus or minus rad 1. And then I subtract 5 from both sides. I get x is equal to -5 plus or minus 1, which is -6 and -4, right? Those are my two zeros. And I believe we have learned everything that we need to for you to be able to do your homework. Have a great day.